Hi everyone, welcome to all of you on my YouTube channel. So I'm Ankit Mishra. I have a 5+ year of teaching experience. I work on Vedanta Aluminum Power Limited earlier. So here I am coming with your PYQ series of solution thermodynamics. Already, if you'll go to my YouTube channel, you can see lots of PYQ. Already, I have uploaded from heterogeneous catalytic reaction system, non-ideal reactor, and again. A process calculation and all of these things. So definitely you will be getting some good benefits of watching all of these lectures for this gate examination 2025. So without wasting the time, let's start with the solution thermodynamics for the gate chemical engineering. So here I'll start with the first question. The first question says that a reasonably general expression for vapor liquid phase equilibrium at low to moderate pressure is this one, right? So this one is a Rolle's law, but Rolle's law, I mean modified Rolle's law, where phi I is the vapor phase fugacity coefficient and gamma is the liquid phase activity coefficient and fi naught is the fugacity of pure component I. The ki value I equals to ki xi is given in general formula as a function of. So whenever we see ki, so ki is used to be a function of your pressure, temperature and liquid phase composition, right? So you have to remember these things. So you can say that liquid phase composition, temperature, pressure, all of these things. Now this was very conceptual question, but again the option, if you read the theory, definitely you'll be able to understand this concept. Now I'll be moving towards the next question. The question says that for a water at 300 degrees centigrade, it has a vapor pressure of this one and fugacity of this one under these conditions, right? And 1 mole of water in liquid phase has a volume of this one, and you are supposed to calculate the fugacity of water at 9000 kilopascal, right? So let's try to solve this question. This question is also from your solution thermodynamics. So when we talk about ln, the formula that ln f divided by f set, that is equals to VL divided by RT and obviously P minus P set. So this formula that we will be using here. So you have been given that fugacity, it has a vapor pressure is given, and obviously vapor pressure is this one, that is saturation pressure, and fugacity is given is this one. So it has a vapor pressure, that's that one, and fugacity that's one. Under this condition, 1 mole of water in liquid phase. So liquid phase volume is also given to you, and you are supposed to calculate the fugacity of water at 9000 Kelvin, and saturation fugacity is also given at this condition. So now you are supposed to calculate F. So you can write ln F divided by F set is given to you, that is 6738.9. that will be in the kilopascal, that is VL. VL is 25.28 into 10 to the power minus 6 meter cube divided by 8.314 into temperature is given 573 multiplied with what is pressure. Pressure is 9000 kilopascal minus P set is also given to you 8592.7 into 10 to the power 3. Is that clear? All of these things are given to you. So when we calculate these things, you will be getting the answer from here, that the value of F that you will be getting, that is equals to 6753.5 kilopascal. Is that clear? So the most important part of this particular problem is this formula. If you know this formula, then definitely you are going to solve this particular problem. Okay, this is a very simple question. We'll move towards the next question. The next question says that as pressure approaches to 0, when pressure is tending to 0, what happens? Pressure will becomes equals to the fugacity, right? So then you can calculate ratio of F by P, that will be equals to approximately equals to 1, that will be 1. Question 9.4 says that if Mi bar, MIR and MIE are the molar, partial molar, residual and excess properties respectively for a pure species I, the maximum property M of a binary non-ideal mixture of the component 1 and 2. So the total property M can be written as obviously x1 M1 bar plus x2 M2 bar. This is very fundamental questions in thermodynamics, solution thermodynamics. You should be knowing these things. When you have, these things, your partial molar property that has been given to you, then if you want to calculate total property, so m will be equals to x1 multiplied with partial molar property for the first component plus x2 multiplied with partial molar property for the second component. So from here, your option A will be your correct answer. Now, next question says that the molar volume of a binary mixture of a species 1 and 2 uh, uh, mm, having mole fraction x1 and x2 is respectively. So just try to understand, your volume V is given to you 220 x1 plus 100 x2 plus x1 x2 and obviously 90 x1 plus 50 x2. So whenever you see this kind of problem, so what you have to do, you have to convert x2 in terms of x1 only first. So that it will be in terms of x1 plus 180 minus 180 x1 plus x1 into 1 minus x1 and obviously 90 x1 plus 50 minus 50 x1, something like that. So volume can be written as that 200 x1 minus 80, so that will be your 40. So I can write 40 x1 plus 180 plus x1 minus x1 square, and inside the brackets you can get 40 x1 plus 50. So once we do these things, 40 x1 plus 180 plus 40 x1 square minus 40 x1 cube plus 50 x1 minus 50 x1 square. So when we do the simplification here, 40 x1 and this one is x1, so obviously you will get 90 x1 and 40 x1 square minus 50 x1 square minus 10 x1 square and minus 40 x1 cube plus 180. Is that clear? The volume you got here. Now I'll calculate del V by del x1. So that is equals to 90 minus 20 x1 minus 120 x1 square. Is that clear? So we have calculated this del V by del x1. That is very much important parameter in while solving this kind of problem. Now coming to, you are supposed to calculate the value of v1 bar when x2 is equals to 0.3, or you can say x1 equals to 0.7, right? So when we calculate dv by dx1, so that is one that used to be equals to v1 bar minus v2 bar, and v will be equals to your x1 v1 bar plus x2 v2 bar. Is that clear? So we are supposed to calculate the value of v2 bar. Is that clear? So from here we can calculate v1 bar, that is equals to v2 bar plus del v by del x1. Is that clear? And we'll substitute these things here. So v will be equals to x1 v2 bar plus del v by del x1 plus x2 v2 bar. So v will be equals to x1 plus x2, that is v2 bar plus x1 del v by del x1. So you can calculate v2 bar is equals to v minus x1 del v by del x1. So this one is the partial molar volume for the second component. Now you can see that v is given to you. So here you have v, that is now you can write v2 bar will be equals to 90 x1 minus 10 x1 square minus 14 x1 cube plus 180 minus x1, and del v by del x1 you have already calculated 20 minus 90 minus 20 x1 minus 120 x1 square. Okay, so the value of v2 bar can be written as 90 x1 minus 10 x1 square, again plus obviously 40 x1 cube plus 180 minus 90 x1 minus plus 20 x1 square plus 120 x1 cube. Is that clear? So when you will simplify these things, 90 x1 and again 90 x1, it will get cancelled out. 10 x1 square, 20 x1 square, so you will be left with only 10 x1 square, 120 x1 cube minus 10 40 x1 cube. So finally you will be left with 160 x1 cube plus 180. So this one is your v2 bar, And now you will substitute x1 equals to 0.7 in this problem, and you will be getting your answer. So this is how you can solve this particular problem. But again, the thing is that what I wanted to let you know these things, just you simplify this particular steps. Once you have simplified these steps, you just do the calculation for del b del by del x1, and definitely most of the time you will forget this formula. So if you are forgetting this formula, I have already described how to derive this formula in a very efficient way, and this will require very less time. Once you have derived this formula, then definitely you will be able to get your answer. Okay, I hope this one is clear. Now I'll be moving towards the next problem of today's discussion. This question has been asked in 2010 gate, and the question says that an equimolar liquid mixture of species 1 and 2 is in equilibrium with its vapor pressure at 400 Kelvin. So temperature is given to you here, that is your 400 Kelvin, and at this temperature the vapor pressure of a species are P1 set. So here P1 set, the vapor pressure of first component is 100 kilopascal, and obviously P2 set for second component is 120 kilopascal. Assuming the Rolle's law is valid, the value of y1, so you are supposed to calculate y1, and Rolle's law is also valid. So you can write y1 into P2 is equals to gamma 1 x1 P1 set. But here there are gamma 1 is not given, then you have to use only Rolle's law, because Rolle's law is only valid for ideal solution. So this equation gives you that this equation is valid for vapor liquid equilibrium, and again you are supposed to calculate these things. So y1, so total pressure is not given to you, right? Partial pressure is given, and whenever this is equimolar mixture, so liquid phase composition will be equals to 0.5. so that thing you should understand. Now second equation you can write y2 into pt, that is equals to x2 into p2 set. So this one is the equation first, this one is the equation second. So if I'll add equation first and second, so you will get total pressure is equals to x1 p1 set plus x2 p2 set, right? But now I'll substitute these things in equation first, and I'll be getting y1 is equals to x1 p1 set divided by x1 p1 set plus x2 p2 set. Is that clear? So finally I'll be getting y1 is equals to, if I'll divide numerator and denominator by x1 p1 set, I'll be getting 1 by 1 plus x2 divided by x1, and again p2 set divided by p1 set. So it's as simple as that. So x2 by x1 is 1, why? Because x1 is equals to x2. So you can write y1 equals to 1 upon p2 set, that is given to you, that is 120 and 180. So I'll substitute 120 divided by 180. So you can write, so that will be equals to 3 divided by 5, that is equals to 0.6. So the value of y1 will be equals to 0.6. So this is how you can solve this vapor liquid equilibrium problem. But this question was very simple. If you know this equation, definitely you will be able to solve this kind of problem. Okay, I hope this is clear to all of you. Now with that, I'll be moving forward towards the next problem of today's discussion. And here you can see the question says that at constant temperature and pressure, the molar density of a binary mixture is given by rho. So molar density is given 1 plus x2. So if I want to calculate the molar volume, so molar volume can be written as V equals to 1 upon rho, that is equals to 1 upon 1 plus x2. Now the partial molar volume of infinite dilution of component 1. So you are supposed to calculate V1 bar infinity is equals to what? So whenever we are going to calculate V1 bar, so first you have to calculate V1 bar, and when x1 tending to 0, that is called as the V1 bar infinity, means this is at infinite dilution. So how to calculate the V1 bar first? So V1 bar, you know the formula, that can be written as V minus V plus x2 del V divided by del x1. Is that clear? But so we have V equals to 1 upon 1 plus x2, that can be written as 1 upon 1 minus x1, that is equals to 1 upon 2 minus x1. So if I want to calculate del V by del x1, so that can be written as these things 1 upon 2 minus x1 whole square. Del V by del x1 you have calculated. So now I can write V1 bar, that is equals to V 1 upon 1 plus x2, or I want to write in terms of x1, so 2 minus x1 plus x2. x2 is 1 minus x1, and del V by del x1 upon 1 upon 2 minus x1. Is that clear? Now, when x1 tending to 0, v1 bar tending to v1 bar infinity. So let's suppose you will substitute x1 tending to 0. So v1 bar will be equals to 1 upon 2 plus 1 minus 0 into 1 upon 2. So v1 bar will be equals to 1 upon 2 plus 1 upon 2, that is equals to 1. So v1 bar infinity, that is equals to 1. Right, so this question was a bit tricky, but you need to understand how can you convert this molar volume density into the molar volume, molar density into molar volume. And once you have calculated these things, then definitely the formula is there for you, that already I have explained this formula earlier, and you will be able to solve this problem. So your option 1 will be your correct option. Sorry, option B is the correct option. Now coming to the next problem, this question says that minimum work W required to separate a binary mixture gases at a room temperature T0 and pressure P0 is W equals to minus RT naught Y1 ln F1 cap divided by F pure plus Y2 ln F2 cap. So F1 cap and F2 cap is in the inside the mixture, right? So whenever we want to calculate F1 cap, F2 cap, so F1 cap can be written as mole fraction, Fi cap can be written as a mole fraction multiplied with F pure, right? So whenever we want to write F1 cap divided by F pure 1, that will be equals to what? Y1, and if I want to write F2 cap divided by F pure 2, that can be written as Y2. So ultimately work done can be written as now my RT naught into Y1 ln Y1 plus Y2 ln Y2. This one is your correct option, and from here you can see which of the following option is correct. So option B is the correct option. Okay, with that I will be moving towards the next problem, and the question says that the partial molar enthalpy of a mixture of benzene and cyclohexane at 300 Kelvin and 1 bar pressure is delta H1 bar is given to you. Delta H1 bar, that is equals to 36 x2 square, and delta H2 bar, that is given as 3600 x1 square, and you are supposed to calculate when 1 mole of, let's say, n1 is equals to 1 and n2 is equals to 2, right? So what is x1? X1 is equals to 1 by 3, x2 is equals to 2 by 3. So mole fraction you have calculated because number of moles of both of these components were given to you, and after that we are supposed to calculate the delta H mixing. So delta H mixing can be written as H1 delta H1 bar plus x2 delta H2 bar. Is that clear? So I can calculate these things. Now this is very simple questions, that x1 is 1 by 3 multiplied with x1 bar, that is equals to 3600 multiplied with 4 by 9 plus 2 by 3 again multiplied with h2 bar is 3600 multiplied with 1 by 9. So basically you can calculate these things now. Delta H mixing is equals to, if you will calculate 3600 divided by 27, you can take common, so you can write 4 plus 2. So delta H mixing can be written as 400 divided by 3 multiplied with 6, so that is equals to 800. So let's see, we have 800 in option, yeah. So you can calculate these things while using this 800. Okay, so you can calculate delta H mixing. So here there was a trick that if you remember this formula, then definitely you are going to solve this particular problem. Is that clear? Okay, if it is clear, then I'll move towards the next problem. This is really a good question. The question says that consider a binary mixture of methyl ethyl ketone and toluene at 323 Kelvin. The activity coefficients equation have been given to you. So here you can see ln gamma 1 is given to you x2 square into again psi 1 minus psi 2 plus 4 psi 2 x1, and again ln gamma 2 is given to you x1 square into obviously psi 1 plus psi 2 minus 4 psi 2 x2. Okay, and here you can say that at the same temperature the infinite dilution activity coefficient gamma 1 infinity and gamma 2 infinity have been given to you. So if I want to write ln gamma 1 infinity, so x1 will be 0, x2 will be equals to 1, so 1 multiplied with psi 1 minus psi 2. So from here you can calculate psi 1 minus psi 2 value, that is equals to 0.4, and this will be your equation first. And from the second equation you can say that psi 1 plus psi 2, that is equals to 0.2. This is equation second. So if I'll add equation first and second, so you can get 2 psi 1, that is equals to 0.6. So psi 1 equals to 0.3, and again psi 2 equals to minus 0.1. So you have calculated the value of psi 1 and psi 2. This is a constant, so this is not going to change, right? Gamma 1 and gamma 2 is a function of liquid phase composition, so that is going to change, but because this is constant, so constant won't be changing in the problem. Okay, now after that what will I do? So you are supposed to calculate the equilibrium pressure, that is P total at toluene containing 90 mole percent of toluene, means mole fraction of second component x2, that is given to you, which is equals to 0.9. So let's try to understand how we can calculate this thing. So now I'll be calculating ln gamma 1, that is equals to x2 square, and again psi 1 minus psi 2 plus 4 psi 2 plus 4 psi 2 x1. Sorry, it is 4 psi 2 x1. Is that clear? So now I want to calculate ln gamma 1, so that can be written as x2 square, so 0.9 square, and psi 2 minus psi 1, obviously we have calculated psi 1 minus psi 2, that is 0.4 plus 4 multiplied with psi 2 minus 0.1 multiplied with 0.1, right? So here this is very simple mathematical equation, so you can get 0.81 multiplied with 0.4 plus 0.1 square, 0.01 minus, so directly you can get minus 0.04. So from here you can calculate gamma 1, and again from the second equation, let's say ln gamma 2, that was equals to x1 square into psi 1 plus psi 2 and minus 4 psi 1 4 psi 2 x2, so minus 4 psi 2 x2. So if I want to substitute ln gamma 2, that is x2 square, so that is 0.1 square into psi 1 plus psi 2 is 0.2 minus 4 multiplied with minus 0.1, and x2 is 0.9. So once you will simplify these things, from here you can calculate gamma 2, and here you can calculate gamma 1. Now what I can write y1 into pt is equals to gamma 1 x1 p1 sat, this is equation first. Again I can write y2 into pt, that is equals to gamma 2 x2 p2 set, this is your modified Rolle's law. So if I'll add our equation first plus second, so you will be getting equilibrium pressure, that is total pressure, that is equals to gamma 1 x1 p1 set plus gamma 2 x2 p2 set. So here in this problem, you know that p1 set, gamma 2 and all of these parameters you have calculated, just you have to substitute this value in this particular equation and you will be able to solve this particular problem, right? I hope this is clear to all of you. But here you have to understand, whenever we talk about the gamma is the function of you should remember these things, and again GATE has asked this question in 1 marks. Gamma is function of obviously temperature, pressure, and again liquid phase composition xi, so and so forth. So here that's why you can see that we had to calculate the value of gamma at that particular composition, because gamma at infinite dilution is given to ln gamma 1, something like that. So that's why you have calculated, or we have calculated the value of gamma 1 and gamma 2 at this particular composition when x2 is equals to 0.9 and x1 equals to 0.1, because in the problem you are supposed to calculate this value at this particular condition, and once we have calculated, you can use this modified Rolle's equation and you can calculate this value. Okay, so I hope this is clear to all of you. Now I'll be moving towards the next problem of today's discussion, and the question says that consider a binary liquid mixture at a constant temperature T and pressure P if the enthalpy change of mixing, so enthalpy change of mixing, that is delta H, that is given as 5x1 x2, and mole x1 x2 is the mole fraction of component 1 and 2, and again delta S of mixing is also given to you, minus R and x1 ln x1 plus x2 ln x2. So then the minimum value of gives energy change. So let's say if you want to write delta g will be equals to delta h minus t delta s. Is that clear? That can be written as 5x1 x2 minus t. T is 300 minus r into delta s is also given to you 5x1 x2, and delta s is negative, delta g minus t delta s, so that will be positive, into r into obviously x1 ln x1 plus x2 ln x2. So let's say this one is just a mathematical function now. So delta g that you see here, this is just a function of mathematics, x1 x2 having two variables, and this function is depending upon two variable 300r and x1 ln x1 plus x2 ln x2. So you want to understand what is the minimum condition of these things, right? So if you are going to plot delta g versus x1, and this will be something like that, and at this particular condition you will see there is a minima, right? And at this particular condition the value of x, where x is equals to x1 and something like that, when you will do the differentiation delta z del of del g divided by del x1, and you have to make it equals to 0. Why? Because for the minima and maxima problem you have to differentiate the function with respect to the independent variable, that is your x1 here, let's say. And in terms of x1, once you will do these things, you will be getting x1 will be equals to 0.5. So when x1 is equals to 0.5, again you will be getting x2 equals to 0.5 also, and at x1 equals to x2 that is equals to 0.5, you will be getting the minimum value of Gibbs energy, and your option D will be correct. So I have not I have not done the derivation, but whenever you see this kind of problem is coming based on the any function, and you are supposed to calculate the minimum and maximum value of any particular function, if this dependent variable is a function of more than two independent variable, then you can utilize this concept. And obviously I hope you would have studied this concept in class 12 also, or if you have not studied that thing, then definitely this is there in your engineering mathematics syllabus in the gate, so you should read these things very carefully. Okay, so with that I'll move towards the next problem. And the question says that a binary liquid mixture is in equilibrium with its vapor at a temperature T. So the temperature is given to you 300 Kelvin. So in gate examination, what I'll say you, so you should be very careful while writing all of these particular parameters that is given in the problem. So it should be very clear to you that whenever you are using, just don't put any wrong data in the problem. The liquid mole fraction x1 of a species 1 is, so your liquid mole fraction of first component is given to you 0.4, and the molar excess Gibbs free energy is 200. So molar excess Gibbs free energy means G excess, that is given as 200 joule per mole. The value of universal gas constant is given to you, R is equals to 8.314 joule per mole Kelvin. But again the problem is, again one more thing that I would like to say you here, that sometimes they will give you the value of R, or sometimes they may not give you the value of R. So you have to remember the value of R with the unit. And the gamma I denotes the liquid phase activity coefficient. So here you have been given ln gamma 1, that is equals to 0.09, and you are supposed to calculate ln gamma 2 is equals to what. So it's very important kind of questions, and again this is from excess Gibbs free energy. So when we write the formula G excess divided by RT, so you know this formula x1 ln gamma 1 plus again x2 ln gamma 2. This is very important formula you can write now. So you have 200 divided by 8.3 multiplied with temperature is also given, that is your 300, that is x1 is 0.4, ln gamma 1 value is directly given to you 0.09 plus x2 is 0.6 multiplied with ln gamma 2. So this question is totally based on the formula. So if you remember this formula, then definitely you are going to solve this kind of problem, right? So that's all. So now from here you can calculate the value of ln gamma 2 that is being asked in the question. Okay, this is very simple question. Now I'll be moving towards the next problem. Again, this question is very important question, and very repeatedly they get used to ask this question. So last 10 years you will see 4 to 5 times they have asked questions from this particular formula, right? So let's see how we can solve this particular problem. So the question says that the given that molar residual Gibbs free energy GR of a molar residual volume VR are related as. So if you relate this formula, so GR divided by RT, that is the formula that can be written as 0 to P VR divided by RT and dP. So here you are very fortunate that this they have given the formula. So sometimes they don't give the formula, but you have to remember this formula. So temperature is equals to 27 degrees centigrade, that is equals to 300 Kelvin, and pressure that is given to you 0.2 megapascal, and the value of Z is given to you 1 plus P by IRT. So you are supposed to calculate the value of GR. So this is very important kind of question. So if you want to calculate the value of GR, so you are supposed to calculate VR by RT, right? So when we talk about V residual, so V minus V ideal, V residual equals to V real minus V ideal. So if I am writing V only, so that is V real. So V residual can be written as, if I take V ideal common, so I can write V divided by V ideal gas minus 1. Is that clear? So now when we talk about Z, Z is compressibility factor, that can be written as V real divided by V ideal. So now I will be substituting this value here. I can calculate V residual, that can be written as V ideal Z minus 1. And what is V ideal? V ideal is equals to RT divided by P. So I can write V residual is equals to Z minus 1 and obviously RT divided by P. Is that clear? So you have calculated this one, V residual is equals to Z minus 1 RT divided by P. So now I will be substituting this value here, that Z residual divided by RT, that is equals to 0 to P, and BR by RT is equals to Z minus 1 and again dP divided by P. So VR by RT is Z minus 1 by P, right? Now Z is given to you 1 plus PB by RT. So now I will substitute this value GR by RT, that is equals to 0 to 1, and Z is 1 plus PB divided by RT minus 1, and again I can say PdP by P. So once I will substitute these things, it will get cancelled out, and I can write GR divided by RT, that can be written as 0 to P, and PB divided by RT and again dP by P. So P and P will get cancelled out, and finally you will get that GR divided by RT, and once you will integrate with respect to pressure, you can get again PB divided by RT. Now you can say that pressure is given to you, that is 0.2 megapascal. So I will write 0.2 multiplied with 10 power 6, and again B, value of B is given 10 power minus 4, 10 power minus 4 divided by 8.314, and you are supposed to calculate GR only. Okay, so again I'll keep these things in terms of RT, it will get cancelled out. So finally, so the value of GR will be equals to how much? 0.2 multiplied with 10 to the power 2, so that is equals to 20. So your option C will be your correct answer. So this is very simple question, but again you should logically know how to connect one formula with another, because this is the beauty of your solution thermodynamics, and you can say this is also one of the major disadvantage of solution thermodynamics. If you logically know how to connect one formula to another, then definitely the subject will be very easy for you. But if you don't know how to connect one formula with another, then this will be very difficult for you. So now this is up to you, in your hand, whether you want to practice a lot for this kind of problem. If you are practicing a lot, then definitely it will be very easy for you. Now the next question says that partial molar enthalpy of a species 1 in a binary mixture is given by H1 bar. So here you can see H1 bar is given to you 2 minus 60 x2 square plus 100 x1 x2 square. Is that clear? And you are supposed to calculate partial molar enthalpy of a species 1 at infinite dilution. So you are supposed to calculate H1 bar infinity, which is equals to H1 bar when x1 tending to 0, right? So now if I will substitute H1 bar when x1 tending to 0, that is equals to 2 minus 60 multiplied with 1 square plus 100 multiplied with 0, that is equals to 2 minus 60, that is equals to minus 58 kilojoule per mole. This is very simple question. So minus 58 kilojoule per mole, right? So this is very simple concept in this kind of in this subject, but again, yes, you need to understand these things, that which formula that can be used here, and how can we deliberately we can solve this kind of thing. Okay, it's fine. Then I'll be moving towards the next problem, and the next problem says that a binary liquid mixture of benzene and toluene contains 20 mole percentage of benzene at 350 Kelvin. The vapor pressure of pure benzene and pure toluene. So here you have been given that P1 set, that is equals to benzene is my first component and toluene is the second component. So I am assuming 92 kilopascal, and obviously P2 set, that is equals to 35 kilopascal. The mixture follows Rolle's law and the binary liquid mixture. So the composition X1 is given to you, contains 0.2 benzene. So X2 will be 0.8. Is that clear? Now the mixture follows also the equilibrium vapor pressure mole fraction of benzene. So you are supposed to calculate Y1 is equals to what? So very recently I have derived the formula that Y1 will be equals to 1 upon 1 plus obviously X2 divided by X1 and again P2 set divided by P1 set. So Y1 can be written as 1 upon 1 plus X2 by X1 is 4 multiplied with P2 set is your 35 divided by 92. So once you will solve this particular mathematics, definitely you are going to get your answer. So again if you'll go to my video, second or third question was from this particular concept. So you can see out of 10 years you are getting repeated concept, right? So solving previous year question is very very important. And again, whenever you are sitting in the actual examination, you will be having lots of practice of, if you have lots of practice of previous year weight question paper, then there definitely you will be getting the clues of the questions, that what sorts of formula that can be used here. Okay, so moving towards the next problem of today's discussion, and the question says that the excess Gibbs energy is given to you. The binary system at a constant binary system at a constant pressure with species 1 and 2 is described by the 2 suffix modulus model GE by RT, that is given to you 3x1 x2, where G is the molar Gibbs energy and R is the universal gas constant, and G1 by R2 that is given to you, and G2 by RT again it is given to you. And yeah, so you are supposed to calculate G by RT. Okay, it's very very important concept. So when we talk about G by RT, so you can say that G excess by RT can be written as Z excess by RT is equals to obviously Z by RT minus Z ideal divided by RT. So here you can say Z by RT can be written as Z excess divided by RT plus Z ideal divided by RT. So finally you can write G by RT can be written as 3 x1 x2 plus Z ideal by RT will be equals to x1 Z1 by RT plus x2 Z2 by RT. So once you will substitute the value, G1 by RT, G2 by RT is given to you and x1 is given to you, that is 0.4. So x2 will be equals to 0.6. So once you will substitute this value, definitely you are going to get the answer. Next question says that the pressure of a liquid is increased isothermally and the volume of the liquid decreased from so here you can see the volume is initially it was 50.45 into 10 to the power minus 6 meter cube per mole, and final volume have been decreased to 14 into 10 to the power minus 6 meter cube per mole. During this process, the isothermal compressibility alpha is given to you minus 10 to the power minus 9 Pascal inverse, which can be assumed to be independent of pressure. The change in molar Gibbs energy. So when we talk about dg is equals to vdp. Is that clear? So you are supposed to calculate change in Gibbs energy delta G. So how can we calculate vdp? So if I am able to calculate vdp, I will be able to get the value of dg. So I can write alpha equals to minus 1 upon v and again del v divided by del p, right? So if I want to calculate vdp here, so I can write minus 1 upon alpha and dv, that is differential change in volume. So finally you will be getting dg is equals to what? Minus 1 upon alpha dv. So what is alpha? So minus 1 upon alpha is 10 to the power minus 9. So 10 to the power 9 minus 9 and sorry, 10 to the power minus 9 multiplied with change in volume. So change in volume is my V2 minus B1. So finally you will be getting this is equals to 10 to the power minus 9 into 48 minus 50.45 multiplied with 10 to the power minus 6. Is that clear? So the value of the value that you are getting from mathematical calculation here, you will be getting, that will be your answer. So this is very conceptual question, but again mathematics is not very difficult, but you have to understand that this relation first, and once you understood this relation, you can get this relation also, right? So that is the two relation that is required here, and you are supposed to know these things. Okay. Okay, so moving towards the next problem, the question says that the vapor pressure of a pure substance at a given temperature is this one. The actual and ideal value of G by RT at a saturated vapor pressure. So actual and ideal is given to you, and here is the fugacity of a saturated liquid at this condition is. So when we write that Z residual divided by RT, that is equals to ln F by phi. If you remember this formula, then these things will be very easy. And what is Z residual divided by RT? That can be written as Z divided by RT minus Z ideal divided by RT. And obviously these two value have been given to you, that is the actual value and the ideal value is given, that is 7 minus 7.7. So 7 minus 7.7, that is equals to 0.7 minus 0.7. Is that clear? Once you have calculated these things, so you have got minus 0.7, that is equals to ln F by P. So what is F? F is equals to P multiplied with exponential minus 0.7. So pressure is given to you, that is I think 30 bar. So that is 30 bar into exponential minus 0.7. So the unit will be in bar. So sometimes they will ask you to calculate the pressure fugacity in either Pascal or something like that. So you should be consistent with the unit, right? It's very important. So the answer that you are getting, that will be the correct answer. So this one is the way that you can solve this kind of problem. Not very much difficult concept was required, but again you can solve this kind of question very easily. Okay, so with that I would like to end this lecture here only, and from the next lecture I will be starting with this question from question 9.19. So I hope in 2 lecture I will be able to complete the whole previous year paper of solution thermodynamics, and after that I will be starting with the distillation mass transfer. Okay, thank you all. And if you have not shared this YouTube channel with your colleagues, please do share with your colleagues, so that those who are not able to avail the top institute while paying the fee, then they can avail all of these free classes from here to learn all of these things, right? And again, this will help you a lot whenever you will be giving your gate paper after going through all of these PYQ series. Okay, thank you all.